get your tickets to Detroit early. If you don't see me, I'll get you a ticket at a slight premium price.
All right, thanks, Larry. And with that, let's jump right into the thermal panel. No pun intended. We have three great speakers. I'm not going to read their bios. They're in the program for you to read, so we can get right into the material. With one exception, we've got Brian Iverson with TSTUD who's going to be speaking. He's the owner of the company, and he's been doing this particular work since 2015. We got Jake in the room, who's been referred to a few times. Jake started at Our Value Homes, and you've been doing that since 2004. And then we've got one of my members, Mark Lee with Better World Builders, and I know Mark and his company well enough to tell you that they're one of the very best home performance contractors and builders in the state of Michigan. So we got three great people here. We're going to jump right into Brian's presentation from TSTUD.
I go fast. Okay, little history. All right, so I'm not an architect, but I have designed 750 structures that have been built. I couldn't tell you how many other ones. I started my career in 1974, so I'm your comedy hour. I know that they didn't give you dessert, so I don't have to kind of do the sugar fix for you. But in 1974, I started doing drywall work in order to afford my drug habit. So I started out young, but I've done lots of mold repair, 2x4 walls that leak like sieves. I mean, I've been through a lot in my career. In 2006, so real estate's D-Day, March 14th of 2006, is the first time that they said that gas was going to go to $4 a gallon. And from that day forward, nobody had any more money in their pocket to pay for gas. So they stopped moving out to the outside country, and they started moving back to the cities because they couldn't afford to drive there anymore. And I know that very well because that's what took me down in 2008. All right, so then I went into the gas and oil industry, so I know all about natural gas. I know about the Bakken oil play in North Dakota. My favorite line for North Dakota is, when the wind blows, there's no place to hide. And my friends tell me that when your dog runs away from home, you still see it running 3 days later. Okay, so that's it for that. I have one more. North Dakota was going to change its name to South Saskatchewan because it sounded warmer. I mean, no lie, in the 50s, All right, so hold on to your seats. All right, next. Okay, this house is under construction right now. We supplied 80 houses last year. We're ready to knock it out of the park. We made a commitment to Buzz and his family. They became shareholders. And this one's under construction by another shareholder. This is $1 million house. This has not one, not two, but 3 dirt roofs on it. And this is the most complicated one that we've done so far. We have 2 extremely more difficult ones coming. So we're a net zero company. We understand a lot because we've been through a lot. This one, back one more. I got to explain something here. This is a Paralam. So the TSTUD isn't everything, but they ran Paralams up, and obviously this has a very big load coming up on top of it in order to hold that up. 16-foot tall TSTUDs for now. Eventually we'll end up at 24 feet. Next. We want a sustainability of the word, structural ingenuity. Next. This is what a TSTUD looks like. There's the frame on the inside, and then we put a polyiso foam in the middle of it to get a complete thermal break through the wall assembly itself. Next. Okay, we're completely code compliant in the United States. We have a Canadian process coming. And how do you spell Canadian? All right, that was me. We have one of our operations is in Fort Francis, Ontario. Next. Okay, we're completely code compliant for 2012, 15 and 18 IBC IRC up to and including 5 stories in height. Next. All right, so here's the deal. So we have a complete thermal break through the wall assembly. Here's the outside, here's the inside. Here's your heat boiling through the wall. Here's your cold boiling through the wall. There's actually some little squigglies on this side. So we actually heated up one wood member. Fana. We heated up one wood member to 194 degrees to see if we could force the heat through it. And you got to get out here and stand out here. Do your job. So that happens to be an R30 T-stud, but the R21, the one that we manufacture and sell today, we got 3 degrees temperature transfer to force it through that wall at 2.5 inches of polyiso after an hour and a half. So I'm not going to poo-poo on putting R5 foam on the outside, but 2.5 inches, we still had transfer. So I'm here to tell you that even an inch, you get a massive amount of transfer. That R30 T-stud right there to replace staggered stud walls, we heated that up to 200 degrees, just shy of starting it on fire. And we had no transfer through 4 inches of foam after 8 hours. So that's why your hot tub cover is 4 inches thick. Hello? All right. So not to pick on anything. Next. Okay. So the entire wall assembly makes up 24% of framing. Bottom plate, top plate, studs, cripples, king studs, jack studs, and headers. 24%. I've seen it as high as 28. We make that back. Banna's partner. We make that 290% more energy efficient just by going from an R6.88 to an R value of 20. That's the math. It's simple math. Next. You're going to see a lot of, I'm here, we're pretty busy on our end making. We're building a new facility in Minnesota. We're going to ramp up production here this fall to doing a semi-load a day. So we're looking for one of the lumber companies to step up to stock here because we have quite a bit of an interest right here, thanks to Buzz and Joel's effort. And so I'm going to talk about the lowly 2x6 wall. And I know I got to go fast from here on out. Okay, 2x6 wall, 16 inches on center, 6.88 for the stud, an R19 bat. The U value is 0.053. That's all it is. Next. R5 continuous insulation on the outside wall. I'm not going to get into all that minutia. U value 0.0425. Next. Here's the new standard, right? Haha. Okay, it is. U value 0.0425. So just with the T-stud itself, but I had to go to an R21 bat, made it the same as putting foam on the outside. So the cost of the T-stud so far has been running between $2,000 and $3,000 for a 2,500 square foot house. That's all it costs extra. That's it. So we're way cheaper than sticking foam on the outside. And you don't end up with that moisture barrier on the outside and put poly on the inside. All right, I got more of it. Okay, here's the T-stud. Top plate, headers. If you shove the header for the architects and engineers, if you stick the header up to the top plate, the bottom of it, you can use the structural value of the top plate as part of your header design. So we had a house in the other day, had 13 LSL and LVL headers. And by the time I got done, we only had 2 LSL headers left. By the time we were done, we saved $500. So we're a value added product. So you just stick your window in there and off you go. There's a T-stud. Next. We have a 99% complete through the thermal break through the entire wall assembly itself. Dowel area. So we're fighting with the state of Minnesota on coming up with what's the value, what is our value of the T-stud. I get tired of them. I live there. Okay, the dowel area, we're actually 0.38%, so we say we're 99% complete thermal break. Continuous insulation area of a 12x8 wall, we say 99%, it's actually 99.62. The framing area, we say it's 17%, it's actually 15.2. So all the time we turn around because we know we're probably going to get challenged somewhere down the line, we're going to undersell and over deliver. Next. SIPS panels. I don't know if there's a SIP panel manufacturer in the room, but you need to change your website. I went on there May 3rd. I just picked this off the website. Expanded polystyrene with stated R value 3.9 per inch. And you see over here, the average U value 0.049. I don't need to say anymore. All right, next. So here, we have this coming. Vanna, where'd you go? So we are working on the ability to sell T-studs without the foam in them. So if you're going to spray foam in the wall cavity itself, so you can buy the frames from us without foam. So we're working on a project right now with BASF at doing this exact project. It's actually a Mississippi River project. Mark Sloot is the architect, and Sustainable 9 Builders is the builder. And so we're selling them the bare naked T-studs. My kids don't like that name. Okay, so the R value through that whole entire wall assembly is 30.99. So U value 0.0323. That's it. So we're cheaper than even on the BASF, they can come up here and talk for themselves. We're cheaper than a SIP panel, and that's what you get right there. Air changes per hour, 0.25. That's what it leaks through the windows. No place left for it to leak. Next. Okay, geothermal. So I was down in Iowa the other day. We're doing a bunch of houses. We signed up another builder there, 40 houses to do. He does them anywhere from 1,000 square feet to $1 million. He covers the whole thing. We got into a conversation about a geothermal heat pump. 20 grand is what he spends, but he could use T-studs, put the spray-in foam with any kind of foam into a T-stud. You're under 20 grand, but no maintenance required, right? No heat pumps to replace. So he said, okay, I'm out. I'm done with geothermal. I'm all in. So he signed up too. They bought a semi-load yesterday. Next. T-stud wall assembly with a fiberglass bat or like a blown-in blanket. Spider insulation was before, or Rockwell makes an R24. Our U value, nothing else, just the T-stud and that one right there, 0.0384. That's it. Not to pick on the SIP panel industry. Next. Fun facts. Average temperature in North America is 55 degrees, but somebody got sued along the way, so you got to state all the R factors and K factors at 75 degrees. So 6.67 per inch is what the K factor is of our foam, or the R value. At 55 degrees, it's actually 7.19. Next. So what climate zone are you in? Depends upon the day, right? Depends upon the month. You guys actually have 5 climate zones here. You have to solve for them all. On average, your climate zone 5, but that's not the truth. So when you design, you got to design to cover every single one. Okay, out with the old. So HFOs, the EPA did get sued. The lawsuit was thrown aside. So as far as I know right now, they are not going to force the foam manufacturers in the entire United States for anything to go to the new HFO blowing agent. But the old HFCs, hydrofluorocarbon, has a global warming potential of 1,000. You want to talk about off gas? Worse than a can of beans. Okay, here's where we're at. We use HFO. I don't like HFO, but they give it that olefin name. Kind of sounds like you can eat it, right? Okay, global warming potential is 1, so no more off gas. Next. Here's the whole story about global warming potential, the whole thing, all the benefits of switching over. So I know that companies are coming up and they're going to start pushing the issue just because of global warming and how much pollution that you can stop going into the atmosphere. I'm not going to get on that soapbox. Next. Okay, maximum allowable. So a T-stud. So our claim to fame when we started out, so we hold 3,600 pounds when we put us on a piece of number 2. When we're over here on MSR 100, we actually hold 5,600 pounds for one stud. But if you put us on a piece of steel, so something that doesn't crush, so we actually crush plates. We actually hold 8,600 pounds. So we're twice as strong as an LVL stud. So if you're architects, so everybody so far, all 80, 100, I don't know how many structures, everything's been at 24 inches on center. Not because of us, but because of our structural ability. And we're one top plate because we're 1.5 times the strength of 2 2x6s in plank because we're perpendicular to grain, not parallel to grain. Okay, so here's all the design values. So you guys send me an email to brian@tstud.com and I'll send you this presentation and I'll send you the Rocky Mountain Institute 0 thing that was mentioned before. I'll push that out to you at the same time I have that one. Values of a 2x6. 425 for bending, we're 889. Next one, compression parallel grain, 725. We upped it to 1150, but we took the modulus of elasticity of this one that we make right now all the way up to 30.3 million. Next. So structurally, we knocked it out of the park. All right, here's where we're going. All right, Habitat for Humanity. I told you I was going to pick on you today. So we're actually going to build a Habitat for Humanity prototype that they don't know about yet. So we're going to have a complete thermal break through the floor, the walls, and the roof because they're all covered by our patents. So this right here is a house built on stilts because I took the money for the foundation and I put it into all the foam in the house, so it was an exact push. no additional costs. When you sign up for 40 houses at a time, you can get the price of the foam and your foaming contractor to a pretty good number. So we have in this house, particular one that we're going to do is an R70 through the floor, R70 through the attic, and we only did the R34 through the wall because that's the only stud that we have available today. And the math says that, oh, Mitsubishi, forgot about you guys, you're here. When you build a house that's this tight, it doesn't breathe anymore, right? You're in a baggie. You're gonna commit suicide inside this house. So we're asking the Mitsubishi for number one to design a furnace, air conditioning system, air-to-air exchanger, and a dehumidifier all in one system, because this thing's not going to breathe. The moisture is not going anywhere. Yep, electricity. You can't afford to turn on the gas range anymore. I cook with gas. I hate that idea, but I don't have a choice. But that's how tight you made that. So now we need the solar panel for backup to run the air-to-air exchanger, right? Because if the power goes out, you have to guarantee to the occupant that you vented the house. And the story keeps on going, but this is coming. This is military, right? They want to go to LEED, platinum or pearl or whatever it is. So that's coming. So we're going to get out in the forefront of everything, just because we can. Next. All right, 24 inches on center for you non-believers. Half-inch high-strength drywall, 24 inches on center. I took it right off their website, right there. Next. All right, this is what happens. So we have there's your 2 2x6s in plank after a 10-minute fire. So if you're the fire department and the wall's been compromised for 10 minutes, the fire department can't go in the attic because that's what's left of your 2 top plates. That's what's left of the TSTUD because that's class 1 foam, type 1 foam. So we don't burn, we char. So that's been 2,500 degrees for 10 minutes, and that's all that happened. So we had 90% structural capacity left over. Next. Axial wind load tables. I'm going to, for you analyticals in here, we passed category 5 and we passed all seismic zone 6. So in fact, we're seismic zone 6, category 5. Let me see, here's 60 pounds per square foot. That's the same weight as putting brick on the outside of a building, by the way. We're at 9 feet tall. We're still holding the whole value at 24 inches on center. Next. Sound transmission. The sound transmission rate through the TSTUD is +6. So we're equal to putting RC channel on both sides of the wall. So the other night, because I spend a fair amount of time in my hotel rooms, I couldn't get to my phone to record good enough. Sometimes it's kind of fun to hear what goes on in the room next to you. And most of the time not. Next. Okay, blowing agents. Blowing agents are a big deal when it comes to spray foam because it's off gases. The insulation companies are pooing spray foam. We don't have any choice but to put spray foam in the TSTUD because it gives us 40% of our strength because of how we have to pass the test. Okay, so not like we're advocates for spray foam, but we have no choice but to use it to get the thermal break through the middle. Okay, so we did choose to go to the HFO blowing agent, but it cost us 6 months on manufacturing because we're actually the first manufacturer to use it starting a year ago. So it sucked. So, right, now you're supposed to applaud, clap, whistle, hooray. Okay, next. Yeah. All right, so 24 inches on center. You save 58 studs on average. You save 2,000 fasteners on average. That's what you save. Okay, next. Oh, and they reduced the furnace sizes. All right, there you go. There's all the headers. There's that. I'm just going to get next one. Fourier's law calculations. I'm going to fly. I might be an analytical. Go. All right, here's Grand Rapids, Michigan. Here's the savings right there, BTUs per hour, 4,000 on air conditioning per hour. That's the savings right there of just using the TSTUD. I know I'm missing 130 days. So if you want all these calculations, I'll give all this to you too. And you can throw in your therm rates for everything. Next. This is how you can calculate all you want, but you don't know how many times you let the dog go out, right? How many times does the door open up, windows open? Calculations all over the place. Next. More headers. Next. More headers. Yep. These are just houses. Everybody has got question. How does the header work? You just stack them up. Next. Okay. The ultimate structure and checklist for structure and the occupants. we're coming with this mold, rot, termites, fire, all in one solution. Next. There you go. A wood building, fully sustainable, 20 stories tall CLT. Average R value, 16.87. It's still impressive. I don't care what anybody says. Next. Okay, you got your choice. Air changes an hour. You change this one right here, you put money in your client's pocket. Otherwise, you chuck it out through that hole, little pinhole. Minnesota knows how to rot walls better than anybody. Next. Okay, you got to decide. You're going to build structures for the entire life. Okay, so this is the last one. I'm gonna end you here. So as architects, designers, you got choices. Design them to last 400 years. You're done.
All right. Great stuff. Jake, you're